All right, Chapter 1, Section 4, Solving Multi-Step Equations. Right there, core concept on the page. To solve multi-step equations, simplify each side of the equation if necessary. Then use inverse operations to isolate the variable. Something I want to point out with that, something that I've realized over the years of doing this, is that the simplify part is PEMDAS. Parentheses, exponent, multiply, divide, add, subtract. The isolate the variable, also known as solve, is SAD MEP, or reverse PEMDAS. Subtract, add, divide, multiply, exponent, parentheses. When you want to simplify one side or an expression, you're going to do PEMDAS. You do parentheses, exponent, multiply, divide, add, subtract. But if you want to get a variable by itself, you want to get things away from it, you want to work from the outside most in. So you're going to do things like add, subtract, away, then multiply, divide, away, then exponent, away, and then you're going to get rid of parentheses if it's buried deep inside there. Now, it does say if necessary on the simplification, because sometimes it is not necessary to do a distribution. Sometimes you can just divide that away, and we'll see that as we go. But multi-step just means it takes more than one move to get a variable by itself. For instance, solve 2.5x minus 13 equals 2. Okay, so that means we got to get x by itself. And in order to get x by itself, we got to get everything away from it. And before we can get rid of the divide, because if we divide right now, we'd have to do it divide the 13 and the 2. We're going to go ahead and just get rid of the 13 first. If we do the opposite of negative 13 by adding 13 to the left, we have to add it to the right. 2.5x equals 15. Now, 2.5 next to an x means multiply, so to undo that, we're going to divide by 2.5, and x equals, let's see, I don't really remember what that is, but if I take 15 and I divide by 2.5, move the decimal, makes a hoop, put a circle in it, 25 goes into 150, well, that's like quarters and cents, so 4 quarters is $1, 6 quarters is 150, so it'd be 6. That should be my answer. Now, notice that it says check your solution. By checking your solution, it means plug it in and make sure it works, because sometimes something you get as the variable equal to, when you plug it back in, it doesn't work. So what we're going to do is take 2.5, take it times 6 minus 13 equals 2. The right side's going to stay on the right, the left side's going to stay on the left. 2.5 times 6 gives us 15 minus 13 equals 2. 15 minus 13 is 2 equals 2. Checks out. That's how you check your solution. Notice I did it. That means you do it. If it says it, you do it. Just plug it back in and check. Now, let's look at combining like terms. We learned about like terms back in pre-algebra. Constant numbers are like terms. X's to the first power are like terms. X squareds are like terms. X to the thirds are like terms. XY is like another XY. The number in front tells you how many of the variable you have. So let's look at solving this problem. On the left-hand side of negative 12 equals 9x minus 6x plus 15, nothing to do, the negative 12 stays. But on the right, we can actually do some simplification because we have some like terms. We have 9x minus 6x. Those are like terms because they both have an x with them. So 9x minus 6x gives us 3x. And plus 15. Plus 15 we can't do because they're not like terms. Now there's no more simplifying to do. So what we can do is isolate, do the SAD map. Move the 15. To move it, we subtract 15 from both sides. That gets more negative. So that's negative 27 equals 3x. That's multiplying. The opposite is divide. So we're going to divide by 3. I promise that's a 3. So x is negative 9. Now notice the x and the 9 switch places, but that's the That's a property of equality that we can do. Okay, the reflexive property of equality. It doesn't matter if it's -9 equals x or x equals -9, it's still equal. Just think about if you had a balance and you had 5 pounds on the right side and 5 pounds on the left side. If you took both of those things and switched sides, it'd still be equal. Okay, check our solution. Let's plug it in. -12 equals 9 times -9 minus 6 times -9 plus 15. -12 equals -81. Now, negative makes positive. 6 times 9 is 45. No, that's 54. Get your fingers right. Be the eraser. 54 plus 15. -12 equals, let's see, let's go -81 and 54. If we go down by 50, that's 31. We go down by 4, that's -27 plus 15. -12 equals, we go down by 10, that's -17. We go down by 5, that's -12. Checks out. Circle it. All right, so solve the equation, check your solution. Try problems 1 and 2 and 3. Give it a pause, give them a try, and then come back and watch me do them and see what the answers are. Okay. Let's see, I'm going to move the 3 by subtracting from both sides. -2n equals 6. Divide by -2, both sides, and we get n equals -3. If we plug that back in, let's see, -2 times 3 plus 3 equals 9. So -3. Negative makes positive 6 plus 3 equals 9. 9 equals 9. Yes, it does. Circle. All right, let's add 11 to both sides. It gives me -10 equals 1/2 c. Now, 1/2 times c, the 1 times the c becomes c over 2. The line means divide, the denominator means by how much. So multiplying by 1/2 and dividing by 2 are the same thing. So if we want to undo divide by 2, we would multiply by 2. So I can take this side times 2, and I can take that side times 2. -20 equals 2 times the 1/2 is 1c, so -20 is c. Let's plug it in and check it out. -21 equals 1/2 times -20 minus 11. -21 equals -10 minus 11. It gets more negative. -21 equals -21. Yes, it does. Checks out. Nice and dandy. All right, let's see. We got some like terms on this one. -2x minus 10x plus 12 equals 18. -2x and -10x is going to get more negative. -12x plus 12 equals 18. Now let's move that 12 by subtracting from both sides. -12x equals 6. Forgot my x there. Divide by -12. X equals 6 over 12. Well, we know it's going to be negative. 6 over 12 would be, 6 goes into both, so that's 1 over 2. So it should be a -1/2. Let's see, -2 times -1/2 minus 10 times -1/2 plus 12. That's supposed to equal 18. Negative makes positive. 2 times 1/2 is 1. 10, negative makes positive. 10 times 1/2. What does that make? That makes 5 plus 12 is supposed to equal 18. 6 plus 12 equals 18. 18 equals 18. Yes, it does. And it checks out. Okay. Let's see. What else can we get to? Using structure to solve a multi-step equation. Okay, so when we talk about this, I'm going to divide into 2 windows here. It's all about how you want to divide it. Doing math is kind of like going to the mall. There's a lot of ways to get there, but you always end up at the same place if that's where you meant to go. So we can take 2 times 1 minus x plus 3 equal to -8. And we can solve it by simplifying the left side first. So doing this distribution, 2 times 1 is 2, 2 times x is 2x, and then the plus 3 at the back minus 8. Then we've got the 2 plus the 3. They're like terms, makes 5 minus 2x equals negative 8. Then move the 5. Negative 2x equals negative 13. Divide by negative 2. X equals negative and negative makes positive 13 over 2. Or 2 goes into 13 6 times with 1 over 2 left. Okay. We can plug it back in to check our solution. 2 times 1 minus 13 halves plus 3 equals negative 8. 1 into halves becomes 2 over 2. 2 minus 13, that's 2 times a negative 11 over 2 plus 3 equals negative 8. Those reduce to 1 gives us negative 11 plus 3 equals negative 8. Negative 8 equals negative 8. Yeah, it checks out. So we do know that 13 halves is the answer. There is another way to do this. There's actually a couple of different ways to do this. But we'll look at one more. Let's say we don't distribute first. We don't have to do that simplification. We can work from outside in, and we could just move the 3 first. Then we can get rid of the 2. Then we can get rid of the 1. We're going to subtract 1 from both sides. So negative x equals 1 is 2 over 2. Negative 11 minus 2 gets more negative, negative 13 over 2. And then if we multiply by negative 1, both sides, that changes the signs, gives me x equals 13 over 2, or 6.5. So it all depends upon where you want to end up with the fractions. I like ending up with the fractions at the end, so I would tend to pick this one. But if it's not a fractionable thing, let's see, for instance, if it would have been plus 4 at the back instead of plus 3, and we got a 12, which divides by 2, that makes it really easy. You can just subtract the 4, divide by 2, move the 1, negate. It works out okay. A lot of ways to get there. You could even divide by 2 all the way across if you wanted to. You could divide by 2. I'll do it in a different color so you could see it. You could do divide by 2 here, divide by 2 here, divide by 2 here. As long as you do it to every piece. If you're going to do it to one piece, you got to do it to every piece. But you could get rid of it all there. Then subtract your 3 halves. And then subtract your 1. And then divide by your negative. And get rid of it. All of that works out okay. You'll get to the same answer. As long as you do your order of operations in the way that you're supposed to, it'll work out. We'll pick up with some examples.